There we go. Okay, so the product rule. Today and then from now on, what you'll find, each lesson, we're just going to learn a new rule now that we've got the simple diff down packed, and we're just going to be constantly applying that. It's going to be lots of fun from here on in. A bit of the chain rule that we learned about as well. So they're good, they're sort of just algorithms for finding the derivative, formulas that we use, lots of cool stuff that we're going to do. And then towards the end of each exercise, there's some challenging questions where we get to apply the rules that we've learned. So the product rule says if we have y, which is a composite function, okay, it's composed of one function multiplied by another function. U and v are functions. So here's two examples for you. 5x is a function, okay, it's got the variable in it. 5x multiplied by 2x take 3, okay, u times v. We're going to use the product rule to find the derivative. Similarly over here, u times v, all right? Now, we could actually solve this using methods we already know, okay? We could expand it and then find the derivative. However, at this stage, we need to teach the product rule, we need to learn the product rule, such that when we go on to derivatives of exponentials, as we'll do, and trig functions, and logarithmic functions, we'll be able to use the product rule. So we learn the product rule, and then in successive exercises, we're going to apply it, and we're going to keep applying it. So this is the product rule, right? What we need to do, let's get straight into it. We need to recognize what is the u function. Okay, the u function is the one that comes first, 5x. All right, and what is the v function? The second one, 2x take 3. And then underneath each one, well, what is the derivative of the u function? If I just focus on 5x, the derivative of 5x will be 5. Very good. And the derivative of the v function will be 2. And then all we do is we just smash that together, all right? If this is y, then dy and dx is this, u dash v plus uv dash. So, sticking with the notation we're provided, they've given us f of x, which means we use f dash of x, and we just type it all in. U dash v, okay, u dash v plus u v dash. All right, and that's our answer. Now we can leave it there. All right, remember, differentiate without simplifying. You get full marks here. If you want, you can expand it and collect like terms. There's plenty of like terms there. Okay, let's move on to the next one. We have u is x to the power of 3. That's the first function. V is the second function, and I'm going to express it straight away. I'm going to express that cubed root of x as x to the power of a third, so that it's ready to differentiate. And then we have take 5x. Okay, so we've got our u function and we've got our v function. All right, u dash will be 3x squared. V dash, all right, we do the power rule to the x cubed. And then simple diff to the 5x. Okay, I think we're getting pretty comfortable with these ones. This is a third x to the power of minus 2/3. All right, nx to the power of n take 1. Okay, so 1 on 3 take 1 will give you the minus 2/3 there. That's our v dash. And let's just smash them together. Okay, again we've got y, so our derivative here will be dy and dx. U dash v plus u v dash. I'm just going to write the chain rule up here as well, because we'll use that in the next question. so that one's the chain rule. That's what we did last exercise. This time we're doing the product rule. And let's have a look at question C. All right, we have x squared multiplied by 2x take 5 root x to the power of 3. Okay, so again, we could solve this one using methods we know, but it would involve expanding that cubic, and that would be very painful. Okay, so here's where we really should be using the product rule. So we can see we've got u times v. We've got one function times another function. So we have our u function is x squared, and our v function is this whole thing with the power of 3 on it. I'll even change that to x to the half in here. So our u dash will be 2x. And for our v dash, this is where we have to use the chain rule, right? We can see, if we're looking at this, I'm just focusing on this component, okay? This is what we were talking about last lesson. Just focusing on this component. I have a function to the power of n, all right? A function to the power of n. I need to use the chain rule. So the derivative of this then is going to be n times the function to the power of n take 1. All right, that's the first part, n f of x n take 1. But then that part, that component, is multiplied by the derivative of the function. So the derivative of this part on the inside. Gorgeous. So I'll just speak specifically to that component. We identify v, pretty happy with that, and then we're just applying the chain rule. So all of the skills we learned in the last exercise, n comes out the front, there's the function, there's n take 1, and then the derivative of the inside goes right there. 2x goes to 2, the 5 just hangs out, and the derivative of x to the half is this part here. And then you just smash all that mess together. All right, well, you've got y, so we're going to answer dy and dx will be u dash v plus, okay, u dash v plus uv dash. Five x to the half squared times 2 take 5 times half x minus half. Okay, and in this step, why it's useful to write down each component is now you're just copying. In this line, you're just copying. Okay, what goes there? U dash, what goes there? V plus U, and then V dash. All right, so get it right here, and then in this step, you just copy. That's your answer. All right, so that's enough to get started on the product rule, 2D. So they'll start easy, they'll get harder, but that's where we'll orientate our efforts today. We may do the quotient rule. I'll just see how everyone tracks along with this one. All right. Any questions about what I've put up?